नमस्ते विद्याओं खुश रहिए आई JVN Muskan Kumari from the Department of Science and Technology and I'm working here as an assistant professor in Vidyapeeth Women's University and the Faculty of Education and Methodology. So today I will discuss the topics in this session. That's topic name is IEEE Standards for LAN, isn't it? Okay, and in which I will discuss also the Ethernets and all the points also. Clear? So today I'm just going to discuss the IEEE standards. Okay, so hold 1 minute. Yes, yeah. Now, if you talk about the your IEEE standards, so here you can easily understand that IEEE standards data follows the data link layer, physical layer, your Manchester encoding, standard internets like the MAC max sublayer, your physical layer, your also the fast Ethernet also, and max sublayer is just the fast Ethernet and physical layers also. IEEE 802.1 defines the basic architecture, max sublayers, and addressing mechanism, and also the frame structure. Okay, so if I will discuss with you the some standards of IEEE. So the Institute of Electrical and Electronics Engineer publishes several widely accepted LAN recommended standards. These standards collectively known as the IEEE 802. Okay, so various IEEE 802 standards interfaces which are given here. So I'm just recalling that names to you. IEEE 802.1, that is for high level interface. IEEE 802.2, that is for the logical link controls LLC, and IEEE 802.3, that is for the used for the Ethernet. IEEE 802.4, that is used for the token bus, and IEEE 802.5 used for the token ring, and IEEE 802.6 is used for the metropolitan area network MAN, and IEEE 802 for 7 is used for the broadband lands, which I will discuss, and IEEE 802.8 fiber optics LAN also, and IEEE 802.9 is used for integrated data and voice networks, and IEEE 802.10 is for the security, and IEEE 802.11 is for wireless network. Okay, so logical link control and MAC medium access control is seen here. IEEE standards for the LAN is you can uh, understand like there are the physical layer which includes the Ethernet physical layer and token links and token bus exactly many nodes, and data link layer contains the Ethernet map, token link map, and token bus map, and the also contains the LLC logical link control, and the other layers are containing the layers whatever. Okay, so uh, data link layer is what? The data link layer in IEEE standard is basically divided into two sublayers. One is LLC, another is MAC. If we talk about the sub points regarding the LLC, then we can say that data link control handles the framing, flow control, and also the error control. In IEEE Project 802, flow control, error control, and part of framing duties are collected into one sublayer called the logical link control. Okay. Now, framing is also handled in both the LLC sublayer and the MAC sublayers. The LLC provides you with one simple data link protocols for all IEEE lands. Now, second more points I will discuss that will be like a single LLC protocol can provide the interconnectivity between the different LAN because it makes the max subway transparent. Okay, now if we talk about the framing, then LLC defines a protocol data unit that is somewhat similar to the HDLC, and the header contains a control field like the one in HDLC. The field is used for flow and error control. The two other header fields define the upper layer protocols at the sourcing destination that uses the LLC. These fields are called the Destination Service Access Point DSAP and the Source Service Access Point SSAP. The other fields which is defined in a typical data link control protocols like the HDLC and move to the MAC sublayers. Okay. In another words, a frame defined a HDLC is divided into PDU and LLC and the sublayers and a frame at the MAC sublayer as we will discuss and say to you. Now, what is the MAC Medium access control. IEEE Project 802 has created a sublayer called the medium access control that defines the specific access methods for each LAN. Okay. For example, it defines the CSMA and CD as the medium access methods for the Ethernet LAN and the token link passing method for the token in and token bus LAN. In contrast to the LLC sublayer, the MAC layer contains a number of distinct modules, each defines the access methods and the framing format specific to the corresponding LAN protocol. Physical layer is one. The physical layer is dependent on the implementation and type of physical media used in that layer. IEEE defines the detailed specification for each LAN implementations. For example, although there is only one maxer layer for standard Ethernet, there is a different physical layer specification for each Ethernet implementation. Now, if you talk about the Manchester encoding, so Manchester encoding is used in this layer. Each bit period is divided into two equal intervals. A binary one bit is seen by having the voltage set high during the first interval and low in the second one. A binary zero is just the reverse, first low and then high. This scheme ensures that every bit period has a transitions in the medium and making it easy for the receivers to synchronize with the senders. Okay. A disadvantage of Manchester encoding is that it requires twice as much bandwidth as a straight binary encoding because pulses are half the width. For example, to send the data of 10 Mbps, the signal has to change 20 million times per second. Now, if we talk about the standard Ethernet, which is for the LAN. So the original Ethernet was created in 1976 at Xerox Palo Research Center, PRC. Since then, it has gone through the four generations: standard Ethernet 10 Mbps, fast Ethernet 100 Mbps, gigabit Ethernet 1 Gbps, and 10 gigabit Ethernet 10 Gbps. So the MAC sublayer frames data received from upper layer and passes this to the physical layer. Frame format: the Ethernet frame contains the seven fields. Ethernet doesn't provide any mechanism for acknowledging the received frames and make it what is known as reliable or unreliable memory. Acknowledgement must be implemented at the higher layers also. Okay, so there might be the map failure like the removal which is of 7 bytes, SFD which is of over 1 bytes, destination address or is of 6 bytes, source address is of 6 bytes, length of the type is 2 bytes, and the data and padding is bytes, and the CRC is 4 bytes. Okay. So now Preamble: the first field of 802.3 field contains the same bytes of altering the zeros and ones that alter the receiving system to commit field and enables it to synchronize. It's also input time. The pattern provides only an alert and the timing pulse. Preamble is actually added at the physical layer and is not only for the part of the frame. Start frame distributor SFD, the second field signals the spring beginning of the frame. The SFD warns the station and station that is the last chance for synchronization. The last two bit is 1 1 and alert the receivers and the next field in the destination. Destination addresses of 6 bytes contain the physical address of the destination station and the stations to be received the packet. Source address is the 6 byte and contains the physical address of the sender of the packet. Length of type is defined as a type field or length field. The original Ethernet is Uh, so this will be the host, your source addresses, and the length of the type is your upper layer protocols using the backplane and the IEEE standards, which is used as the length field to define the number of bytes in the data field also. And the data is basically encapsulated from the upper layer protocols, and it is in the minimum of 46 and the maximum of 1500 bytes. Okay. And if you talk about the CRC, so CRC is basically used for methods and techniques which is used for detecting and correcting the errors which is generated in the data packets. Clear? So this is basically all about your IEEE which is used in your LANs. So students, if you have any problem regarding this session, then please mention the query into the comment section box through which I will discuss this query in our session with you. And please read this IEEE, it's just like the whole about your theoretical. And please read the sessions also from the standard book version and also use the multiple open access websites through which you can read this really knowledge about this session also. Okay. So one more questions will arise through this. Please define the H2.3. These are again you have to explain the how the land, IEEE land. Okay. Yes, okay, thank you.